We modify microorganisms so that they produce the dyes, but also so that they deposit and fix the dyes onto the fabric. By doing this, we can address both sides of the impact of dyeing, the impact of making the dyes and the impact of applying them.
Hey, Rum, what's going on?
Oh, Carl, wow. Living life. How are you doing?
Look, we both were traveling and we went to different parts of the world on different weeks. So, for our listeners, you don't miss us because of the continuity in our pre planning. But you went to Spain. Where exactly did you go?
Yes, I went to the Basque country, which is wow, Carl. I feel very fortunate to be able to travel, first of all, and I know a lot of people don't get to travel as much for whatever reason, but like I just feel very fortunate. And every time I go traveling, I'm always thinking of biology, biotech, and what's happening there, and just learning about the culture. And Basque country, I know you've been there, so it's fun to talk to you about it, but it's so incredible that the civilization there, the Euskadi people, have been there for like 25,000 years. And just, you can tell how knowledge has been passed through all the generations when it comes to the food and drink and the way they take care of themselves. And I just am so blown away by the Basque country. And, like every time you go to Europe, you always feel like, why am I living in the US? But then you come back to the US and you meet your friends and family and freedom and America. But yeah, anyway, it was super, super great. I just cannot stop thinking about it. It's a part of me now. And I can't wait to share some specific stories as we go through this podcast about that beautiful region.
What was your highlight for your trip to Euskadi?
Well, we did a road trip. So we flew into Madrid and we got a car and we drove. First, we went to LaGuardia, Spain. You just see these medieval towns sprinkled throughout, and the landscapes are so gorgeous. So my favorite thing was just driving through this region, 3 hour, 5 hour stretches of driving, and it went by very quickly because you just are so enamored by what you're seeing, and you're like, this is amazing. I mean, yes, eyes on the road for sure because I was doing the driving, but like, you feel it when you see it. Obviously you're stopping by, and there's rest stops, but the rest stops, the food in there is incredible. They have fresh baked bread, and they have all sorts of like cured meats and cheeses and honeys, and it's just like every rest stop was like a gourmet market. Just like, what?
Yeah.
It just, and then they had like a full blown cafeteria, and like the cafeteria had just amazing Michelin star food in this cafeteria on the side of a road, and I'm like, what's going on? Why don't there's no moment in the Basque Country that you're not having an elevated experience.
Yeah, I mean, we went last year, and no shade on the rest of Spain, but like I've only gone to that part of Spain. I've only gone to Green Spain. We did a Pinchos tour. Pinchos are the tapas of the Basque region. I'd spent 10 days there before, but then we also just drove across northern Spain so we can go hiking into Picos Europa. But like every place we stopped, it was the same experience you had. And I think there's a reason why Spain is probably one of the top three tourist destinations in the world. It's got a ton of history. The people are super friendly. The food is fantastic and not super expensive. And I loved it too. So I'm glad you went and had a great experience.
I can't believe that I went on that trip. I mean, just I feel like it was a dream. It was so beautiful. Just we went hiking, and there were these valleys that were so green and lush, and these beautiful white sheep like just hanging around,
Yeah.
and and then like the shepherd with the bell, and I'm like, did I
Go back in
transport
time.
somewhere? Yeah, and I felt like it was like a Wes Anderson too, like just like every color, everything was like so well done. I loved it. But yeah, and then you were traveling. I know you went to the home country, the mothership.
Yeah, so I went down to Panama. The vibe is different. You get there, there's a sense of relaxation. I'm very familiar with it. So the moment I step off the airplane, I can just take a deep whiff of Panamanian air. It's really heavy, tropical, and this time of the year, it's the summer. So it's very dry. I was down there for work. I was working. I met someone who's working with the Science Commission of Panama. Our friend Francisco from Argentina is talking about setting up his program to help scientists do startups in Panama. So I was talking to his representative there, a woman named Katja Went. And I took my son Felix, my youngest, who's 19, he was on vacation. So we just basically spent our time eating. And we did drive to the beach one day and got caught up in some traffic coming back. So what was normally a 90-minute drive turned into a 5 hour sitting in the car, because the Pan American Highway goes from Alaska to Patagonia. But otherwise, it was really good, and it was very, very relaxing.
Wonderful. Wonderful. Well, now I'm glad you're relaxed. I'm relaxed. I mean, I was like, before we even started recording, I'm like, I need to get my energy back up because I just feel so chill. But here we are talking about biotech. So many amazing things have been happening while we were traveling. You shared this Bloomberg article. Why don't you share it with our audience?
So a couple of weeks ago, Bloomberg published an article that was titled "Humans Have Found the Keys to Mother Nature's R&D Lab," and it's by Gautam Mukunda, who teaches at Yale. And he basically makes the argument that all the technologies that are used to develop medicines actually will have a lot of impact on the $6 trillion global chemical industry. So that, in other words, he's basically talking about what we talk about here on Grow Everything, which is basically smart people using the tools of biotechnology to change industries. It was a really nice article. To me, it's the best mainstream biotech article so far of the year. He also points out that he was inspired by a National Geographic article, which had come out, I think, in the month of March. And the cover shows a spider web, an engineered spider web holding up a truck tire. And the point is that spider proteins woven into silk are so strong that they can be stronger than steel. So we'll put a link to this in the show notes. I wrote about it on LinkedIn. I think it's a really great view and preview of what we talk about here on Grow Everything.
Wow, yeah. I love the fact that, yes, mainstream news talking about biotech, being able to take a different perspective. Like, one of the things is that we are working in this industry, so we go very deep at times, although we try to bring it back to the surface so more people can understand what's going on in this industry, or using these tools, try to bring out some of the nuance. But when you hear someone who's not in the industry, who took a deep look at what's going on in this biotech industry and hear how they reflect on it, it's amazing. And so I really encourage everyone to read it. It just, even if you are working in biotech, especially if you're working in biotech, to be able to use different ways of talking about what you do and how it works, it's important. And that's probably why I listen to this podcast too, to find different ways to explain what you're doing. But here we are.
So the other big science news was the fact that the Artemis space mission went around the moon, went the furthest that humans have ever gone away from space. Erum, you're the space pro. What was your take on this?
I'm glad that there was a manned mission that went around the moon to probably test out that they could do it. I would love to see them land on the moon and do some experiments down there. I mean, I'm a big fan of For All Mankind, the amazing show on Apple TV, where they do set up a station on the moon, and that's in the 60s. I mean, that's if things kept going the way they were going back in the day. But I'm like, let's get there. Let's start having people live in different types of environments besides the International Space Station. And there's so much to be gained from learning about how biology is experienced or evolves or interacts in low Earth orbit or different environments, whether it's the moon or Mars. And it's just wonderful to learn about. Were there different experiments that were happening that you know about on the Artemis mission?
Yeah, but I want to just interrupt for 1 second. You were talking about it For All Mankind. Did you see Project Hail Mary yet?
Yes, and I had it in my notes. I don't know why I didn't add it, but yes, I watched Project Hail Mary. It's, whew. I mean, that is a whole other episode. We got to get Neil deGrasse Tyson on here and talk about it. Did you watch it?
Oh yeah, I saw it when I was in Panama. It was a long movie, but it was amazing. I'd read the book, and actually, as the movie was winding down, I was like, wait, this book doesn't end this way, because I thought they were going to end it, and I don't want to give away any spoilers, so I was really happy that they stayed true to the book.
Okay, good. Yeah, I think it was just well done. I mean, obviously the cinematography, I mean, Ryan Gosling, of course, was great, and all the actors were great, and just the science. Wow.
A lot of problems to be solved, and being able to solve them with an alien, not to give it away, but learning to communicate with another being, that's part of the book, part of the movie, was just amazing.
Yeah, I mean, and the science and the space biology and this isn't a giveaway, but the alien is made of chemicals you think that are actually only gaseous, but where they are from, it's solid. And you're like, wait, yeah, I guess that could happen theoretically. So yeah, what a great movie. I mean, yeah, for me being the space nerd, it was a chef's kiss.
Okay. So, going back to Artemis, yes, there was biology. This is something that I could really relate to because what they were doing was they had something called Avatar, which was tissue on a chip. And on a chip, kidney on a chip, lung on a chip. This is something that has been being developed for many years. In fact, my college roommate, Ed Kelly, is a professor at the University of Washington, and he's been working on kidney of a chip his whole career, or a good chunk of his career. And so what they were doing was tissue on a chip to study how deep space radiation and microgravity affect human bone marrow stem cells. So as we know, as scientists or people who aren't scientists who are tuning in, they may not know that you have bone and muscle loss in space because you don't have gravity pushing you down. So one of the things that people do to counter that in space is they do a lot of exercise, but they're trying to figure out how does space and microgravity affect human bone? Because if we're going to go on these long space missions and we're going to go to other planets, there's not going to be gravity there. How's it going to affect our bodies? So I was super excited to see that this tissue on a chip study was being done. And we'll just have to report on this as more information comes out.
Yeah. Because then, if they need to learn how radiation affects bone marrow or different parts of the body to create radiation therapies, so then, you can maintain and repair your body throughout different space missions, especially if they're generation ships. You know what I mean? Like if it's going to be you and then your offspring and their offspring and their offspring, which is, oh my gosh, mind blown thinking about it like that.
Yeah, and I don't feel like, maybe I was watching Aliens Romulus, or I can't remember what I was watching, where the guy wakes up after being asleep for a long time and the computer is warning him, you're not going to be able to stand up, you're going to have a hard time. Maybe that was when Ryan Gosling wakes up on Project Hail Mary. I'm starting to confuse things. But it's true. If you're sitting there and you've been hibernating for like 30 years, your muscles are going to be atrophied. So that first couple of days are going to be hard, even in low gravity.
Yeah. Unless there's some type of technology or therapy that's, maintaining your muscle health somehow. That's interesting. There's a startup for you.
For sure. And we are looking to get more space experts, space biology experts on. So stay tuned for that, listeners, because we are very interested in that area.
Yes. And before we deep dive into deep space, we're going to deep dive into a different part of biology, and that is the world of colors. And so I'm really excited to share that we're going to be kicking off our series on biodyes, and we'll be interviewing some incredible people that are creating, building, and making dyes out of biological systems. Now, why are we doing this, Karl? We'd love to hear some of your perspective, and we can kick it off.
I think at a very high level, first of all, biology is great at producing colors, and we're lucky that you can go outside and we're just surrounded by color. If you think of the different colors just on bird feathers or flowers, nature produces this incredible palette. And we're in an interesting time in the world where you have a lot of concerns around health when it comes to synthetic colors, because the dye industry produces hundreds of millions of tons of dyes and pigments that are produced from petrochemicals. A whole other industry has arisen seeking to replace petrochemicals by producing natural colorants. So these are companies that are extracting from turmeric, from beetroot, but there's not enough space on the planet to produce the colors that we need. So now you have a whole other set of companies that are new, that are producing colors either in mycelium or in microbes, and doing it either in a vat or some other natural way. So we think that this is a really important thing to do. And there are legal precedents. Erum, do you want to talk about the tailwinds for biodyes?
Yeah, absolutely. I mean, and especially when it comes to food. So when we're talking about dyes are everywhere. They're everywhere, obviously, in your clothes. They're in furniture. We use them so much. They're so pervasive. And, of course, we use it in our food. And traditional food dyes are made synthetically. They're made through petrochemicals. And I'm sure a lot of you have heard about this. And like red dye 40, there's all these different colors. And people just started doing some research and noticed that there could be some very adverse effects. And there's been an effort here in the United States to phase out synthetic dyes this year and next year. So RFK Jr., the whole MAHA movement has been behind this. And it's very interesting. It's very interesting to see that there are these large companies looking for solutions because of the amount of food dye that they use is significant. And the alternatives, like you were saying, those that are made from beetroot or turmeric, are expensive. So that could really affect the pricing of products and their bottom line. So they're looking for alternatives that can not only be cost effective, but also be high performance. So that's another thing, is that these natural colors, they often have thermal instability, they have pH instability when they're used in food processing. We had Ricky of Microma, who talked a little bit about this when we featured the winners of the Future of Fungi Awards. We did talk about this in December, but now we're going to be deep diving into it. We'll have him back on and some amazing people, which we will be teasing out throughout the next few weeks. But today, in particular, this episode is a replay of a previous episode where we interviewed Orr Yarkoni of Colorifix, and they focused on the world of textiles. And it's very interesting to hear after, I don't know, I think we interviewed him like a year ago or so.
A little bit more, yeah.
A little bit more than that. And how, it was a kind of it was my first foray into really deep diving on dyes. And here we are just kicking off our BioDye series.
That's great. So with that, let's let Orr take it away.
Orr Yarkoni, we are so pleased to have you on the Grow Everything podcast today. Thank you for joining us.
Pleasure to be here with you, Karl and Erum.
So we've known each other for a little bit of time, I feel like. We keep running into each other at events. Can you give us a little bit of background on yourself and then your company, Colorifix?
So my name is Orr Yarkoni. My background is in synthetic biology. So a bit of molecular biology before synthetic biology really took off into more mainstream science. Did my master's in nanomaterials and nanofabrication, so a lot of surface chemistry. And then did my PhD and postdoc on biosensors, so interfacing cells with the environment and trying to get them to interact. And then from there on to Colorifix, where we were originally applying our biosensor work, myself and my co-founder, Jim, in South Asia, where we were measuring the amount of heavy metal in drinking water using biology as a sensor for whether the water was at toxic levels of arsenic. And when we were there, we asked people, what else is in your water that bothers you? Right. And through that exercise, we came to realize the extent of the impact of the textile industry, and particularly the wet processing and dyeing steps in processing fabric. And we realized that we had a microorganism that would change color if the water wasn't safe to drink. Wouldn't it be great if we could change the color of the fabric instead of measure how much pollution that process is making? And that was the inspiration.
Wow, that is incredible. Can you talk a little bit about this microbe? How was it a biosensor, and did you have to change it at all to have a new application?
So this was for the arsenic biosensor collaboration, the collaboration between the University of Cambridge, Edinburgh, and local stakeholders in Nepal in the form of ENFO, a water and air quality NGO. We were developing a bacillus-based biosensor that it would change color if the thresholds of arsenic went above the 10 ppb WHO current standard, the 50 ppb WHO previous standard, and 200 ppb to denote heavy contamination. So it was designed in a stoplight fashion. So you had different lights that would turn on at different thresholds. It was an engineered microorganism with a credit card sized container that would be self-filling and self-leveling. So you dip it in the water, incubate it between 30 and 37. So basically recommend it in the pocket. And then you could take the reading within 24 hours. It included a negative and incubation control to make sure that you've incubated for enough time to read the result. And ultimately, it showed to be quite efficient. The problem is regulation and funding a product that doesn't produce significant revenue or profit. So that's part of the The journey into Colorifix is realizing that in order to really solve a problem, you need to provide a solution that isn't just good, but that does well on the market. In order to get the backing, you need to actually create real impact. And that was a lesson that was hard to learn, but important and very helpful to Colorifix's journey.
Now, you mentioned that you asked people what else was bothering them about their water, and they mentioned dyes from the textile industry. How does traditional textile dyeing work, and how does it impact the environment?
So in conventional dyeing, you're doing two activities really. First, you're producing the dyes, right? So you're processing petrochemicals into the fine chemicals you intend to use, the colorant. Then there's the impact of actually dyeing, and that's where you add the colorant, other chemicals to help the colorant interact with the fabric, and lots of water, salts, and other chemistry to help the reaction take place. And then you boil it at high temperature for a long time, right? So basically, you're creating a fairly toxic soup, lots of it, to get the colors to stick to the material. The industry uses roughly 700,000 tons of colorants a year, out of which roughly 200,000 tons end up in effluent. So the transfer process is fairly inefficient. The industry uses upward of 70 other fairly toxic chemicals to get the dyes to stick. Over 30 of those are irretrievable, meaning no matter what your waste management strategy is, those will end up in the water if they're not disposed of by incineration or other means. Beyond that, the industry uses trillions of liters of water, and the figure will vary depending on which report you read, but there's a lot of consensus around roughly 5 trillion liters of water being used for wet processing in textile manufacturing, and most of that for dyeing. And again, on the emissions, you'll have varying reports of between 17 and 7% of carbon emission contribution coming from textiles. And that will really depend if you're looking at just the manufacturing or all the transport, supply chain, and retail activity before the end consumer receives the item.
Wow, that's a lot of processing and inefficiency. It's incredible. People just don't know, right? I have a background in biotech and more biopharma, and I worked in tech for a while. And as soon as I started working with Karl and going to Biofabricate, I've heard you speak a couple times. I didn't realize that petrochemicals made dyes, whether they're food dyes or dyes for our clothing, and it's just insane that this was even created this way. But I guess in retrospect, yeah, it's just insane.
It's really interesting because if you look at the history of chemicals, two of the largest, Bayer and BASF, actually started as dye houses, right? The Bayer Ash and Soda Factory is BASF, and that was literally a dye house and a producer of dyes. The chemical industry, as we know it today, owes a lot to the textile industry. And even to this date, between 20 and 25% by volume of chemistry goes towards textiles. And depending on the product, you can get up to 1.2 kilos of chemical to process 1 kilo of fabric before you wear it. So it's a phenomenal amount of chemistry going on, from the material to the processing to the finishing to even putting a scent on so that it smells nicer in the store. Everything adds to the impact.
Unreal. So talk about, you had this sensor, you guys realized that there was an issue with dyes, and so you pivoted to make Colorifix. What does Colorifix do, and how does it offer a more sustainable alternative to this very toxic dye problem that we're dealing with?
So when we were working on the biosensor, again, we had a bacteria that changed color if the water wasn't safe to drink. And then from there, the inspiration point was, can we transfer the color to the fabric? Because what Colorifix does is provide biological dyeing. We modify microorganisms so that they produce the dyes, but also so that they deposit and fix the dyes onto the fabric. By doing this, we can address both sides of the impact of dyeing, the impact of making the dyes and the impact of applying them. And it's actually on the application that you see most of the savings, because that's where you use a lot of water, a lot of energy, and a host of other chemicals rather than just the processing of the petrochemical to the final compound. So what we do is find colors in nature. We, instead of extracting the pigment from the natural context, we borrow the information of how it's made, meaning the DNA sequence. We engineer our microbes to make these same pigments the same way they're made in nature, meaning starting from sugar and nitrogen and building all of the biochemistry towards making the colorant. What's special about Colorifix is post-fermentation, there is no downstream processing. We harvest everything from the fermenter into the dye machine. So what comes out of the fermenter is literally the dye liquor. In some cases, it's diluted even, but there's no downstream processing for our main product lines in dyeing. There's some level of downstream processing for printing, but that's a separate application that we're working on as well. There is no binders, linkers, mordants, any of the traditional auxiliary chemistry to have the dye stick to the fabric. All of that is done using biology. So that helps us a lot in the impact. And because the process is done roughly at body temperature for the most part, with a brief temperature spike to inactivate the microorganism, and we use less water per kilo of fabric, you end up saving a lot on water and energy and the total amount of pollution you make. And on the matter of pollution, it's really important, obviously. There is no change to the waste stream management in the textile industry. They already do everything necessary to handle our waste type. And in fact, we've been deemed safe for direct discharge. So we've been assessed by water quality authorities over the last few years, and they found that this is safe enough to even potentially put down the drain, despite that not being something we advertise doing industrially. We still want the three-phase EPC, just as the industry does today, as any shortcuts can lead to disastrous consequences for the environment.
Now, you had said that on the traditional chemistry side, it's like 1.25 kilograms of chemicals for every kilogram of textile processed. How does your process compare to that? Is there a direct comparison?
So there's a reduction in it will depend on which product. The example that we were discussing then is on polycotton, which takes the most processing. There are fabric types that take less. Overall, we've shown 65% reduction in the total chemistry used for dyeing. And all of the chemistry used is green chemistry, meaning nothing hazardous going into the process. We see a reduction of between 77 and 78% in water consumption, 19% on energy, and this is factoring that we're measuring making and applying the dyes versus just applying the dyes. That's spectacular. And we're saving 31% on carbon emissions.
Wow. Yeah, I bet the ESGs, I mean, though we're like, it's very controversial at this stage, but you're checking off a lot of boxes. So congratulations on that front. I really loved how you said we borrow information from nature. Can you talk a little bit more about how you borrow information to make specific colors, and what type of colors do you borrow, like a red from a rose and then make it like what? Can you tell us a little bit more about that biological reasoning behind that?
It's a great question, and it's core to what we do. So nature makes lots of colors, and it makes them in different ways. For our process, we're looking at specifically pigments and dyes. So it's a chemical molecule that will confer that property of color to any material. There's structural color, for instance, like you see on butterfly wings and peacock feathers. There is fluorescence and luminescence, but those don't have the properties necessary for textiles because they need to be wash fast, light fast. They need to have the same quality as the products that we're replacing. So key to what we do is not just find colors, but find colors that have the required performance to truly replace the products and not just look pretty. Yeah. So light fastness is the biggest barrier for most natural dyes, as they don't have the same resilience to UV. So to give you an example, the best performing natural purple dye that's been available to the industry historically had a light fastness score of 0.5 out of 5. Okay. The industry standard is 3/4 or above. So 3.5 or above. Our first purple gave us a score of 2.5, and we now have one that scores above the industry standard. And that's looking at colors that, again, are only present in nature and finding ones that meet the performance to truly replace these products on textiles and not just have something that looks good. Because if you make something greener that doesn't last as long, it's not actually more sustainable. It's just a bit greener.
And what does that look like when you guys are out looking for these colors? Like, what's your source? Is there a preferred source? I mean, nature has so many places where we can look to find colors, but tell me what that mining process looks like for you guys.
So we look for pigments and dyes that have been historically trialed from fungi, plants, and other sources that are easily accessible and have been tried for hundreds, if not thousands of years. A great example for this is indigo, one of the most used dyes on the planet. But there's lots of diversity in indigo plants. So you'll see different shades of indigo. There's more than one product in the plant that gives color. And we actually have, I believe, 18 different color variants of indigo, ranging from greens to grays to even pinks and purples and blues, the traditional one. Indigo is also found in other places in nature, right? So again, it's interesting that nature solves the same problem the same way in different places, and that can sometimes be useful for marketing. So, as an example, one of the colors that we've developed previously, the organism that we found the sequence in was a microorganism that is often found in decomposing vegetable matter, right? So, narrative wise, for people to wear this color comes from garbage, but you can also find the same exact compound in archaebacteria growing in geysers, right? Which, from a marketing narrative, is much more appealing. So, guess which one we used? But the fact is, it's the same pathway, the same pigment. And we get to cherry pick a little bit based on where nature provides that for us. So that's on the scoping part, right? And then we decide, okay, this looks like a good candidate pigment or dye. And the difference between those, just for definition's sake, is really solubility. Um, Once we decide we want to develop this, we look at all the different instances in nature where it's made, pick which contexts we want to use, so which genes, which regulators we want to put in. We make a host of strains based on that pathway. We screen to get a strain that makes the color, and that's the first part, right? So making the dye producing organism. Then, because our process works on lots of materials, it's not locked to just naturals or synthetics. We can do polyester, cotton, silk, wool, nylon, etc. That means we then need to test that color against every material and then check the performance of every material, because sometimes we develop a color that gives performance on, say, cotton and polyester, but not nylon or wool, right? So then we need to develop a different product of the same color range for these other materials. So there's a huge amount of work that goes into qualifying the products that we develop and make sure that they fit the customer need, because the last thing you want is to tell the customer, I have exactly what you're looking for, and then they tell you this doesn't work for me at all, right? That's the worst message you can get, and it will impact your growth and market penetration. So we focused a lot on making sure that the quality of the products we're providing to the industry meet or beat the standards of the products you're using today.
You know what you say in terms of like, okay, we've developed these dyes, we have to customize them based on the material that you're going to be dyeing. That would be the case with chemical dyes anyway. It's not, it's not a one size fits all kind of thing, just so that it's clear to our listeners.
Oh, absolutely. In fact, today in conventional dyeing, you need different chemicals, different machines, and different settings for each one of these materials. For us, it's actually one set of settings, one set of products to do all of these different materials. It's just we replace which is the cartridge, if it's going to be polyester or cotton, etc. But the process is the same, and we can use the process regardless of equipment or stage of production. So yarn, fabric, garment, or print, natural or synthetic. The versatility is one of the key features for the customer of what they can do with the technology.
Yeah, because it's so exciting. I think we're just so excited about this. I mean, I think one of the things that would be really helpful to know is, can you tell us a bit more about your customer and the industry? Are you selling to textile houses? Do you work with fashion brands? Where do you fit? And who are you selling to?
So when you look at the supply chain from us looking up and down in the process, the dye house is where the activity is going to take place. There, we do direct sales of the hardware that they'll use to run the process, meaning fermentation, because we do fermentation on the customer site where it's going to be used. We also sell the media, meaning the food for the microorganisms, so that to ensure the product quality and sustainability, we have all of our ingredients and products certified with a leading industry certifier, Ecotex, to the highest standard. And that includes the media provided for production. So to the dye house direct sales and the hardware and the media. We make a partnership with the mill, which is the primary and many times the only customer for that dye house. From there, we take a royalty, and I won't go into a lot of details there. And ultimately, this is to service the brands who are looking for more sustainable ways to produce products for their customers, who are the average consumer, who is finally demanding more sustainability.
No, I mean, I will just add to that because you have these dye houses, and one of the big things that we've been seeing when it comes to fermentations is that there's a lot of challenges scaling up technology. So, what are some of the challenges that you've encountered, and any advice that you have for other people that are using fermentation to serve an industry?
Absolutely, that was a huge step for us. So a lot of biotech and synbio applications, I wouldn't say easy, but much more feasible to get to a proof of concept stage. The scaling up, the technical challenge of fermenting at scale, the costs involved in scaling up, and the infrastructure required generally is incredibly expensive and can take a very long time to set up. And that's even when you're only looking at one product. In our case, we need to make every color for every material. So that's a lot of different products and different fermentation SOPs that need to be followed. So we never wanted to go and do fermentation ourselves. We were looking for the customer to buy hardware from existing suppliers, use their tech support. And what we saw early on is that each dye house slash mill was looking at different fermentation equipment at different scales from different makes. And if we were to go forward that way, we'd need to develop different solutions for every customer because their process is slightly different. The solution would have to be slightly different as well. And that would kill the scalability faster than anything else would, because if our team isn't solving the same problems for every customer, our team has no chance of making the customer happy. Beyond that, as we mentioned, fermenters are quite expensive. So for commodity chemicals like dyes and pigments, the capex involved is simply too expensive to make it viable. So we decided to own the problem and actually distribute hardware to the customer. So it's always the same hardware, and our team is working to the same process and standards at each location. We made it a little bit easier for the customer to use because the goal isn't for our fermentation scientists to operate the machines, it's for dye house machine operators to operate the machines. That involves getting a lot more automation in place and making sure that we minimize all of the maintenance and consumables required. So removing the need for filters, removing the need for parts that you need to take apart between cleaning cycles, and streamlining everything so you have the minimum amount of downtime possible. As a result, customers that are using our hardware have basically 2 to 2.5 hours downtime between batches. This is because everything is steam in place, clean in place, and almost entirely automated now. We've had really good feedback in that we now have teams at dye houses routinely running the fermentations with remote assistance only. And this is just occasional beginning of the week to go over the plan and any issues that they have. And yeah, so hardware was a big one. In our case, because we don't have any downstream processing, we don't need to centralize to make better use of the CapEx. We can just distribute the hardware to where it's going to be used. And that's a big advantage because otherwise we need to open a 300 million plant and wait the couple years until it's up and running and then start sales, which is a long time and carries a lot of risk, which is again an area where a lot of biotech and synbio companies stumble after the valley of death, right? There's the desert afterwards.
And just to put things into perspective, how many dye houses are there in the world? Number one. And number two, what kind of reaction do you get from them when you go in and you talk about, hey, we've got this new hardware, it's going to make your process more sustainable?
So, as far as number of dye houses, it's kind of hard to pinpoint exactly because even brands that are trying to trace their supply chain and spend billions on tracing their supply chain only have visibility on the tier one vendors, and dyeing and dye houses are considered tier two vendors. As a global estimate, there's between 4,000 and 7,000. That is a wide range. And it really depends on whether you count two dye houses belonging to the same group as two individual dye houses or not. But in any case, it is in the thousands, but under tens of thousands for dye houses. And then you have a larger number of mills than dye houses as well.
And just to be clear, the mills are where the textile is being woven.
So the mill are the ones that own the textile. So typically, depending on what fiber you're talking about, it'll go through a spinner, weaver, and then it will go to the mill. And then from there, it'll go to the cut, trim, sew factory, right? And whilst it's at the mill, it will typically go to the dye house for certain processing and finishing. And then it will go over to the factory to be cut into the final garment that we wear.
Yeah, when you're mentioning hardware, you're talking about a fermenter, or is it also safe to say a bioreactor? Can we call it that too?
Yeah, no, it is essentially a bioreactor. It's aerobic fermentation that we focus on, and yeah, the instrument is compatible with other biotech applications as well.
Okay, yeah, because I wanted to get to that in a second. Because how big of a bioreactor we're talking about? Like how many liters does it range?
So we currently provide two models for the customer. We're working on further scale up to the next stage, but at present we offer 300 liter and 3,000 liter.
You mentioned that it's applicable to other SynBio applications, and I really wanted to dig into that because that SynBioBeta last year, you brought this up. You talked about your approach. You talk about the bioreactors. I would love to learn about what you were thinking behind that. What type of SynBio applications first came to your mind, and are you working with other SynBio company today?
So there's a couple of companies that have approached us since, and we're trying to set up the project. Again, we have a lot of demand on the textile side, which we can't really sacrifice. And some of these companies need more time to put the funding together for their purchases. The application space is in aerobic fermentation specifically at this stage. One of the partners is looking at other types of fermentation because our mixing technology is applicable to non-air mixtures of gases. So we're looking to explore that as well. But at present, we're focusing on aerobic fermentation, works for both minimal and rich media, works across yeasts, both gram-positive and gram-negative bacteria. And we validate across a host of different pathways that we ferment as part of our work. Yeah, I think those are the key ones. We don't do solid state fermentation or filamentous fungi at this point, but we know that this is an exciting area. And maybe in future we'll work on the hardware for that. But at present, we really need to focus on making sure it works as well as possible for our direct customers. And a lot of those needs are the same as most SynBio companies have. The advantages with the hardware are the lower maintenance costs, as well as less replaceable consumers, as well as a drastically lowered price point, as we're selling the 300 liter for 150,000 euros to Biotech, the 300, and the 3,000 for 300,000 euros.
Just so that our listeners have a picture of what these looks like. Correct me if I'm wrong, or I seem to remember the picture you showed. They kind of look like an oversized washing machine.
Kind of, to an extent. There's a lot of elegant tubing involved, but in essence, you needed to mix the liquid and the air together, keep temperature, monitor pH, and a lot of the clever stuff is actually in the dashboard that you press the buttons on to make everything work kind of seamlessly.
So maybe more like a complicated stove washing machine together. And these machines would be very, very similar to what someone at a dye house would be used to using anyway.
Correct. I mean, dye machines essentially, the only difference is you're not monitoring air. You're monitoring pH, temperature, pressure, all the rest of the stuff, as well as the color at the end. And the same type of risk, same type of operation. It's just different equipment for a different purpose.
But it is also a less toxic processing. So I bet the teams and the workforce at these dye houses are just thrilled that they have a more sustainable process. And I don't know if you know about any of the effects that people at traditional dye houses experience with this toxic process. I mean, is that a situation?
The impact is noticeable, and it really depends on where in the world you're doing it, what the local practices and regulations are as to how much of a difference it makes for health and safety and the workforce. A lot of the chemicals used today are harmful to humans and the environment. They are using extremes of pH, with the amounts of soda ash being quite alarming, to say the least. And when spillages happen, people get hurt. In our case, unless the temperature is high, that's not going to happen, right? And that's a big advantage for us. One of the things that we do as part of our certification is we test for cytotoxicity, skin contact dermatitis, and allergenicity as part of the certification. And we do that on what comes out of the fermenter going to the dye machine, meaning the liquid. We do that on the fabric, which is the person who's going to wear at the end, and on the waste that comes out as well, to make sure at no point is something toxic inadvertently being made or deposited either in the waste or the material that people wear.
I am curious. So, and I know you've been scaling up and really, actually, can you tell us how long you guys have been operational?
So we started the company in 2016, actually timed with SynBioBeta to make the announcement. We raised our first funding round in December 2018. We were 4 people at the time. Since then, our team's grown to over 100 now. And yeah, raised a considerable amount of funding and developed quite a significant amount of products at this point.
That's what I'm really interested in. I mean, obviously, congratulations. That growth is amazing. It takes a lot of work. And the fact that you have a team of 100 people sings volumes on your leadership. So, congratulations on all of that. I am really curious about the product. So, like, what is the most popular material that you're dyeing? Are any of those clothing on the market, or any? Can you tell us a little bit more about how consumers can see Colorifix in the market today?
So we've had a few product launches. The first notable one was this Pangaya in 2021, November. We've somewhat recently had a release with Volback as well. I believe there may be some items left in sizes that are not so popular, but we are currently doing production on a couple of other things, which I can't unfortunately go into because brands like to talk about their own releases. As far as materials and demands, I would say that our product range is currently widest for synthetics like polyester and polycotton. I would say it's weakest for cotton, with wool and nylon being somewhere in between those. So, as a factor of that, we are seeing more demand for recycled polyester and recycled polycotton. We try to funnel whenever it goes synthetic, we want it to be recycled synthetic rather than virgin whenever possible. We know that brands have some exceptions to this, particularly looking at some of the new formulations for polyester products that make it biodegradable and non-microplastic forming. So we're working with a company called Ocean Safe, who make a saltwater degradable polyester. So we're quite excited about that.
Amazing. You guys have been around since the late 2000 teens. And in that time, have you guys formed any strategic partnerships or collaborations that you could talk about?
Absolutely. H&M has been a key partner for us. They believed in us early and invested in our first Series A and have continued investing as we grow. They've been really great at introducing us to different players in the supply chain to have a better understanding of the customer needs and pains, as well as all of the different sustainability initiatives that are taking place in the industry and how we can best integrate with the existing efforts, because that's always a value add if you can show the customer how you're solving a pain they already trying to solve, rather than highlight a pain from an angle that they're not looking at it. We've been fortunate to receive investment from impact investors that are helpful in establishing the LCAs and metrics that we should be collecting, as well as some in the SynBio and Biotech area to, again, help us on recruiting and network and potential collaborations, such as we have with Basecamp at this point.
Great, great. Congratulations on that. So here's a question for you. Of all the colors, which one is the most popular and which one's your favorite? By popular, I mean the one that you sell the most or that makes the most amount of textiles. And then which one's your favorite color?
So, of the color range we currently have, the most popular is the blue. In the textile industry, the colors by rank are pretty much black, navy, and white make up between 70 and 75% of all products sold, and the rest is the rest of the colors. So black is a big priority for us. We don't have a black that has the performance we want just yet. The blue is taking off well, and we have a blue for cotton and a blue for polyester and polycotton as well. And we have a new blue coming out for nylon, and we have a blue for wool as well. Sorry. Um, so blue is one of the colors that we have solved for most materials already. Black is the biggest priority. After that, I would say red is the other big one because we don't have a good performing red. We have a good pink, we have a good yellow, we have a good blue, and those make the primary colors for mixing. But just like with conventional pigments, we can mix the colors to achieve the desired hue.
And black is a challenge, right?
Black is a challenge for a number of reasons, in that most of the instances of black that you see in nature are either structural or constantly recycled color, meaning a product that fades and the organism is making more of on a continuous basis. There are some exceptions. Some of them don't have the fastness properties. Others have cytotoxicity properties that make them less amenable for the industry, but they'll have other applications. And the most famous black is obviously melanin, which is used throughout nature. And that is actually a combination of pigment and structure because it's a polymer that's being formed. We've had some things that look black, they don't perform as we like, and it's just a matter of time until we have a black we do like.
Yeah, I'm under the impression that black is the harshest on the environment. Is that true?
Yes, again, the degree of impact will vary on what you're dyeing. Is dyeing cotton black and dyeing polyester black and dyeing nylon black are different things. But all of the black recipes are the most chemical intensive. They tend to be the longest running in the machine because you're trying to get as much color onto the fabric as possible and at the highest temperatures with the most other added chemicals. So it is the worst one. And the new EU guidelines are actually phasing out some of the top selling black products and pigments on the market, not just from manufacturing, but from being sold within the market. So there's going to be a big scramble for the next black in the industry.
Wow, that's amazing. The cynic in me is like, how do we turn the ban of black into a cultural war issue?
The reality is the fact that black being banned is the result of a cultural war already. It's been a couple of decades of environmentalists fighting for improved standards, particularly in fashion and particularly in wet processing, starting, I believe, in 97 with the Greenpeace Fashion Report, which named and shamed quite a few brands in their supply chain. And since then, there's been increasing and growing pressure, both internally from within the industry and externally by consumer and regulator on what products and how production takes place. And I think it is a good thing that we're seeing some of these products phased out. I think whilst these highly polluting and cheap alternatives are available, there will be less drive to adopt sustainable production means. So we need to phase those out as a prerogative, as a species, in order to give the planet a fighting chance.
Yeah, you mentioned black, navy, and white being the primary colors that are being used in the fashion industry. And that is the color of Carl's wardrobe, too. That's the only colors that he has.
Oh,
That's why he's so concerned about the black dye, because that's all he wears, being a New Yorker, of course. So that's, yeah, just like so fascinating. I actually went down a little rabbit hole in my brain when you were talking about the bioluminescent and the fluorescent colors that are found in nature. Did you and your research team play around with that at all? I mean, I know you said is it a structural color?
so in that case, it's the fluorescent color. And we can make glow in the dark fabric. That's not an issue. The problem is when you put it in the washing machine, that effect comes off entirely, right? As those colors come as an effect of the protein that's on the fabric rather than a chemical compound. And when you put it in your washing machine with detergent, which is proteases, it will just break down the protein. So we have made these things in the past. It does work. You can make it glow, but as soon as you kill it and wash it, then it comes off the fabric. So it's a wear once kind of thing. And that goes against what we're trying to do.
Right, I see. Can we do like a skunk works and make like a coating that protects the proteins so they don't wash off and just we'll have a small company on the side that makes fluorescent and bioluminescent clothing.
The coating is an interesting one there. The coatings that are currently used by the industry are also being phased out. particularly the hydrophobic ones, which would be protecting things like what you're discussing. So there are solutions needed in that area too, not just for potential fluorescent colors, but for existing products on the market where the finishing products are being phased out and there are no great alternatives still available.
We know some companies that are working on it, right, Carl? The company is called Material. Have you heard of Material?
She was at Biofabricate with us.
Oh, okay. Yeah. I don't know if that's waterproof coating, but anyway, see, this is what happens. You say bioluminescence, something I'm a very big fan of. I want more in our world besides just in plants that, yeah, Light Bio made their plant. I know there's a bunch of other companies that are now making bioluminescent plants, but as a color in clothing, so interesting.
Yeah.
So, or as we kind of wind up the interview, what do you see as being the future of biotech in the next 3, 10, 30 years? How does what you're doing evolve and affect textiles?
Well, I think we will see much of the same type of evolution that we've seen thus far. Basically, the 80s, we started engineering microbes to make pharmaceuticals, right? It took roughly 30 years for us to see applications outside of that and start to grow the application space. I think over the next 3 to 5 years, we'll see a host of diverse products that are manufactured biologically, showing proof of concept and examples of how to introduce biological manufacturing to different verticals. I hope that in 10 years' time, those will be successful and will spawn competition and new product verticals trying to compete with those biomanufactured products. And I hope that in 30 years' time, much like has happened with pharmaceuticals, half or more of production of day-to-day goods that do not need to last forever and that we need to eat or wear, we make biologically. That is, I believe, the future because nature's shown that the only carbon economy that really works sustainably is sugar, right? Any other form of carbon that you can't make using sunlight ultimately doesn't last forever. Otherwise, nature would be using that instead.
Yeah, I think that's a great, great point. Was there anything that we didn't cover that you think we should have asked you today? Or
Last thing I will probably want to mention is that one of the cool and kind of weird things that we do is that we can harvest color from any natural context. And the industry so far has only had available a context that's scalable to them, meaning plants, minerals, certain insects are the only ways you could make color, extract color naturally so far. And we can extract it from any context, be it a microbe, an insect that's so tiny and has that pigment in milligrams, and we scale everything the same way. So a lot of the pigments and dyes that we're working with are ones that the industry's never been able to play with before because they simply weren't scalable solutions, even though the products were interesting. So we can actually deliver on those and bring a new natural color palette to the traditional ones of alizarin and indigo, Tyrian purple, those things that we know for thousands of years. I think the exciting thing is all the colors that we've never been able to see and touch that exist in nature.
that's amazing. And just you did mention you guys have a collaboration with Basecamp. Can you talk a little bit about that?
We can't go into a huge amount, but I can tell you it's towards improving some of our products on cotton specifically. As I mentioned, the cotton is the one area where we need to improve our product portfolio. It will be towards improving some of that.
And I think of Basecamp as being kind of like looking for non-model organisms for very specific applications. Is that right?
Also, and bespoke enzyme evolution and tailoring, and a host of other interesting things that they're doing at the moment. I think there is a lot of potential there.
Yeah, fascinating. Well, I don't think we have any other questions at this point, but thank you so much, Orr, for your time today. This was a great conversation.
I'm glad you enjoyed it as well, Carl. It was a pleasure. Oh, one thing that you asked me in the email that we haven't covered is the favorite tech film. I actually put a lot of thought into that. I'd like to share with you. So the film is called The Man in the White Suit. So it's 1951, black and white film. So not for everybody, but definitely worth a watch as I haven't seen many films that look at science and industrialization with so much comedic accuracy.
Wow. That's one I haven't heard before, so I can't wait to check that out.
Wow. And black and white, so no colors. So it must have been refreshing for you.
Yeah, it's not something I usually engage in, given color is everything now. But that movie really was special and resonated, particularly with us as it's in textiles. But it should resonate with most, if not all, scientists, because once you see it, you'll get it.
Got it. Yeah.
Okay, we have to watch that. Then when we do the reflection, we'll talk about it.
Right?
Cool. Thank you so much for the recommendation.
Excellent.
No, thank you so much, Karl and Erum. Pleasure. See you.
Hey, this episode is sponsored by Messaging Lab. At Messaging Lab, we translate complex science and economics into compelling business narratives. And we have done so for the most successful biotech forward companies across pharma, agriculture, personal care and beauty, materials, and the list goes on. We're here to make sure your ideas not only get heard, but resonate with your audience. So if it's time to amplify your company's voice and elevate your business, visit us at messaginglab.com. Let's grow.
Well, I hope you enjoyed that replay. Erum, we're going to be on the road a bit in the next couple of weeks. Do you want to talk about what we're going to be doing in DC?
Yes, yeah. So we're going to be at DC Climate Week. We'll be recording a live podcast. We're going to be interviewing some incredible investors, Veronica Breckenridge of First Bite Ventures. We also have Michael Luciani of Juniper VC, as well as our friend Justin Brody Comit of Lichen Ventures, who actually came up with this idea. So you want to give Justin a shout out. And some other people. We're going to have a great conversation really about biomanufacturing in the United States versus what's going on in China. I mean, we're in DC, so we do want to have this spin on what our governments are doing to support biomanufacturing and the bioeconomy. And we're going to learn from people who are investing and creating policies around it here in the United States and what they've learned about what's happening in China and other regions, so we can learn and also grow our bioeconomy here. And so that's really exciting. And the name of the panel and this live recording is The Road to Remake Almost Everything. So let's excited for that. I'm excited to go down and do a road trip. So Karl will have some fun there. And we have other things that are coming up. We'll be at SynBioBeta, where you'll be moderating a session. So will I. And my session is going to be about colors, hence this biodye series. It's all coming together. So if you are interested in coming to SynBioBeta and listening to Karl and I moderating sessions and just be there and meet all these amazing people that are builders, makers, doers, investors, please come to SynBioBeta. Use code GROWEVERYTHING for a discount for your attendance ticket. And with that, Karl, is there anything else you want to add?
No, I just want to say thanks for tuning into the Grow Everything podcast. If you have any questions or comments, please reach out to us. Our contact information is in the show notes. And don't forget to subscribe, like our Substack. Let's grow.
Let's grow.